इंग्लिश, हिंदी और बांग्ला तीनों वाले लोग होंगे। हिंदी कम होगा शायद, लेकिन इंग्लिश और बांग्ला वाले लोग मिक्स होंगे। लेकिन मोस्ट ऑफ द जो पहले के लोग थे मोर और लेस इंग्लिश में ही दिए हैं। बीच में बंगाली बोलना आपको तो मुश्किल, तो हिंदी ऐड कर दीजिए। 10 बजे 11 बजे का टाइम दिया हुआ है, सो 11 बजे 5 मिनट है टाइम, 3 मिनट और टाइम। Sitendu, are you ready?
Good morning. Yeah, ma'am. Yeah.
Good morning, ma'am.
Good morning. Good morning to all of you.
Good morning, everyone. Ma'am, should I start the program?
Can you wait for another 2 minutes because our program is at 11?
Okay.
Yeah.
Yeah, actually, this program is very good in terms of school students. They are really liking it. Teachers का feedback बहुत अच्छा है।
नहीं, ये तो है एक्चुअली जो है बच्चे जो है क्लासरूम में जब पढ़ते हैं, so they read in confine of physics, chemistry, mathematics, subject wise. So whenever they get an opportunity to discuss issues, तो बड़ा अच्छा लगता है बच्चों को भी। तो मतलब क्या कहते हैं सब्जेक्ट लाइक दिस, और इट कुड बी सिंपली मतलब जैसे कि पानी के ऊपर है या बिजली के ऊपर है, हाउ मतलब इलेक्ट्रिसिटी कम्स टू योर होम, मतलब इट्स ए कंप्लीट चेन, बट बच्चों को पता नहीं है, वो समझते नहीं है मतलब। और इसमें सारा फिजिक्स भी है, केमिस्ट्री, इंजीनियरिंग भी है, मैथमेटिक्स भी है।
रिसेंटली मैंने एक स्कूल में दिया था, स्कूल का वर्चुअल मोड में, उसमें अबाउट ग्लास हिस्ट्री एंड इट्स अप टू मॉडर्न यूजेस, हाउ इट मेल्ट्स, कुछ वीडियो जोड़ दिया, कुछ children and teachers really enjoyed, and about 200 students from there. It's a big school. Actually Jamshedpur का school था. They liked very much. Lot many things I got. So really I also felt good to talk to like that.
नहीं, मैंने ना एक बहुत पहले हमारा जो एक मिनिस्ट्री है अर्थ साइंस मिनिस्ट्री, उन्होंने एक किताब निकाला था समुंदर की दुनिया। That time they were called Department of Ocean Development.
पढ़ने वाला,
हाँ,
अभी अर्थ साइंस,
हाँ अर्थ साइंस।
तो आप कुछ बोल रहे थे?
नहीं, मैं बता रहा था दैट बुक वाज रियली, मतलब जैसे मैंने तो डीएसटी ज्वाइन करने के बाद पढ़ा, बट इट वाज सच ए रिवीलिंग बुक कि नॉर्मली our children do not know about our sea or marine resources. तो मतलब पानी तो दिखता है, उसके नीचे क्या है पता नहीं।
Correct. Because the topic as you have chosen will be very, very comfortable to the students. This earthquake and the vibration of the tectonic plate and their movement during that journey, how it behaves and what is the reason behind it and all those things. They should also understand, and such popular talk will be very interesting to the students.
Yeah.
And that's the basic purpose of this Jigyasa model, actually, the awareness of the scientific temper among the young minds.
In fact, frankly speaking, I will be also one of your students today.
We are all
much about earthquake today, but then nevertheless I would touch it briefly.
So should we start now? It's 11.
Yes, ma'am. Yeah, we can start. Dr. Jui, can you? Yeah, you can start the program.
Yes. Thank you, Shitendra. Good morning, everyone. Today we all have gathered to celebrate our very own CSIR Jigyasa program, the 4th webinar in the series, which is basically a scientist-student connect initiative and is launched by Government of India with the objective of New India Mission and is based on scientific social responsibility or SSR of scientific community and institutions. With this brief introduction, I'll now request our Director, Madam, Dr. Shuman Kumari Misra, to deliver welcome address, please. Madam, please.
Thank you. I welcome all the school children, their teachers who are connected with us today. My today's speaker, a very distinguished one, Dr. S.K. Varsne, from Head International Division, Department of Science and Technology. We are very much thankful to you, sir, that you agreed for this request by CGCRI. I very well welcome all the organizing committee of the CGCRI, Dr. Sitendu Mandal, who is actually the chairman of organizing all the CGCRI Jigyasa under the Jigyasa program, different lectures, different programs, Mr. Prashant Sinha. There are many other, and Juhi Chakrabarti. I welcome you all students who are from my colleague who have joined today to this lecture. They are also, please accept my hearty welcome. Actually, Jigyasa is one of the major initiatives of CSIR. This was started with so that the Student Connect program, they should learn. So it has an advantage in that this program would explain the culture of curiousness and scientific natures on the other. The CS Council on Scientific Industrial Research has launched a Student Scientist Connect program, Jigyasa, in collaboration with the Kendriya Vidyalaya Sangathan throughout India. And the sole objective of which is extending the classroom learning and focusing on a well-planned research laboratory-based learning. The student residential program, scientist as a teacher and teacher as a scientist, teachers as a scientist, lab-specific activities on-site as well as online, experiments, visit of scientists to school and outreach programs, science and math clubs, project of National Children's Science Congress, and tinkering laboratories are some of the activities which has been included into this program, and it is being organized by all CSIR institutions through entire the country. And CSIR, CGCRI is one such who is also very actively participating in this program. The highlights of Jigyasa is that it would inculcate the culture of inquisitiveness on one hand and scientific temper on the other among the school students and their teachers. They can change there after that the way of teaching, the way of how they deliver things. The program will also enable the students and teachers to practically live the theoretical concepts and learn them taught in science by visiting CSIR laboratory and by participating in projects. For this, they are school-wise, maybe we club 2-3 schools and they come and visit. But because of pandemic, last 1 year, nobody has visited. But we are thinking to open it gradually. It is planned by CSIR about more than 1100 Kendriya Vidyalayas should be connected beside the other local schools of that. So everywhere Kendriya Vidyalaya may not be there, but main program is with Kendriya Vidyalaya. But we have connected each time probably not less than 200 students are attending this program in each lecture. As I saw, about 10 schools must be participating, teacher and right, Sitendu Mandal, it's right. That kind of figures are there. About 10 schools are joining.
Yes.
This classroom learning is a very well planned. Our scientists have, beside the lectures, scientists have made the online virtual experiments to show them if they are not able to come, say melting of glass, making a ceramic product for CGCRI. Like this, the virtual experimentations have been made, and that also is a program, and more are being made so that the student really gets attracted towards these areas, and they can take as a research career in these and entrepreneurship in these areas. With this thinking in our mind, CGCRI right now, because at the pandemic we are not able to do the actual visit to the students and teachers. So we are going more on a virtually, and we are just waiting when it will be really, we will be able to call students and teacher in our premise, and we can really give them actual exposure, more exposure. But in this series, we have a couple of programs, and every month we are trying to have a one general topic which is very much beneficial to the students, to call one very dignitary and who are who are have a very good knowledge for those students which will connect. So not only we are seeing their knowledge, we also sometimes we are seeing their positions too, so that when a good position people come and they become the role model for the student, it becomes much more motivating. This also we have taken care, because positions also, after all, we are a society that gives the so and so has done so, one can reach. Otherwise people think that whether science lene se kuch hai nahi, everybody has to do computers. Computer is very good today, artificial intelligence, other things are very important, but there are many things. India doesn't have a manufacturing. India needs many more understandings of many subjects, which still it is an open. Students are the future of this country. With this in mind, today we have Dr. S.K. Vashne. With this, I will, and we are, including me, I am a student also for you today, Dr. Vashne, because I know less about the earthquake, actually, how does it happen. So I once again, welcome all of you. Over to Julie. Thank you very much.
Thank you, ma'am. Thank you for your encouraging and informative talk. And I think students must know what we scientists are taking up in laboratories, and to the society also. This information is very important, and this program is, I think it is taking care of that. And now I request Shitendra Mandal sir, scientist and head, specialty glass division and nodal officer of the Jigyasa program, to introduce the speaker, Dr. S.K. Vashne sir, please.
Thank you, Dr. Jui.
Sir, over to you.
Good morning, Director Madam. Good morning, Dr. Varsini. Good morning, all the students, teachers, and my colleagues, and who are the invitees are there. Yeah, really, this is a very good program, and this program has been chosen in such a way that we need to focus on the common, on the content of the common popular talk that should bring the scientific temper among the young minds, so that they should come out as a scientist, because science is the main thing. Unless we do promote the science, then the development, the total development of the country, of the nation will not be complete. So we need to have more scientists, and the students who are studying in the level of class 10, class 9, 11, and the 12, they should think of, and they should have a dream that I should be scientist. Particularly the students who have invited today, they are coming from the far remote corner of the West Bengal state, and our also main objective is to reaching the science to them, so that they can also understand what exactly the scientists are doing in the context of the national science and technology policy taken by the government of India. This is the fourth webinar, and we are very lucky enough and fortunate enough to have with Dr. Varsini among us. Really, the talk which he will be talking today in this webinar, it's a very interesting topic, and definitely it will be enriching the knowledge base to the students. And as Director Madam very correctly pointed out, that we all are your students. And we also want to know how the earthquake happens and what are the actual movement of that. And that's why the topic you have chosen is very pertinent on this particular topic. As you know that every scientist has a famous background behind his professional career, academic career, and all those things. And today Dr. Varsini is famous for that, and that is why you are very fortunate enough to see him in this webinar over virtual mode. And if you listen to me if you listen to me regarding his career, then definitely you will start your preparation of your dream to become Dr. Varsini maybe after some point of time. Dr. Varsani is currently the advisor and head International Cooperation, Department of Science and Technology, Government of India. His full name is Sanjeev Kumar Varsani. Sanjeev Kumar Varsani is the head of the International Scientific Cooperation in the Ministry and Department of Science and Technology, Government of India. He joined Department of Science and Technology in 1990 and is facilitating the international scientific cooperation from Department of Science and Technology with its bilateral, multilateral and regional scientific partners. He is Indian co-chair, governing body, Indo-German Science and Technology Center and Indo-US Endowment Fund, member board of directors of a private limited company, Global Innovation and Technology Alliance, GITA, and is member governing councils of I am naming them, US India Education Foundation, USIEF, and International Advanced Research Center of Powder Metallurgy, ARCI, Hyderabad. He is an Indian focal point for BRICS Working Group on Science and Technology and OECD Committee on Science and Technology Policy, Government of India. He is a member Board of Research Studies in the Department of Geology, Aligarh Muslim University. Dr. Varsani has worked as Counselor Science and Technology with Embassy of India in Moscow to facilitate the bilateral scientific cooperation between India and Russia during the April 2008 to June 2011. For 3 successive years, he has been contributing for promotion of international scientific cooperation as well as the scientific industrial cooperation as well. He completed Masters in Geology in 1984 from Aligarh Muslim University with University Medal for obtaining the first position. He qualified Joint UGC CSIR NET in 1985 for Junior Research Fellowship and Lecturership as well. He pursued research at University of Delhi during 1985 to 1990 on Himalayan river systems, sedimentation, diagenetic and tectonic modifications as well. He was also awarded Dr. D.N. Wadia Research Scholarship in 1986 for his outstanding research on Himalayan geology. Dr. Varsani is a Life Fellow of Geological Society of India, Bangalore, Nepal Geological Society, Kathmandu, and member of International Association of Sedimentologists, Oxford. He also has numerous certifications to his credit. He also taught at Kurukshetra University in 1990. He has written several articles on science policies focusing on international scientific cooperation. He is also involved in science popularization, for which he writes in newspapers and magazines through online and through offline. Such a famous man, we are really enough fortunate to have him with us. I now request Dr. Varsani to deliver his keynote lecture as a chief guest of this particular webinar. Over to Dr. Varsani, sir.
Thank you, Sitendra Da, and namaskar to everyone. It's my pleasure to be here and talking to all of you. And topic which I have taken today is something which is quite interesting. And this is about continental drift and plate tectonics. I think all of us know that the planet we are living is quite unique. This is a broad slice, if I could say, how Earth looks like. And this is only a part. So lithosphere is a part where we are living. So man is normally living on the land. So, and lithosphere is quite complex, and it is divided into several parts, like the top layer is called earth crust. This is something we know maximum about. And then there are other parts like upper mantle, lower mantle, inner core. And this all plays a very, very unique part in the history of Earth and its behavior. On the top of it, of course, we know that we are the only planet in the solar system, which is at least known planet, which is having air and water. And because of this combination, life is possible. Life is here in different forms, be it plants, small animals, birds, or large animals, or human beings. And then there are several landforms. So we have sea, we have mountains, we have other things. Our atmosphere is also composed of several parts, and we will not discuss today much about it. But what I'm trying to say is that our planet, we know mostly information about the top layer, that is Earth crust, and activity which is happening here through hydrosphere and biosphere. So today we are going to discuss what are the natural processes that shape up the Earth. This is how our Earth look like on the map. But is it always like that? Or it takes a lot of time or whatever time to get it changed? So this was one of the questions which has been bothering scientists for long, and at least for last 300 years. People have been discussing that Earth is not the same every day. So you can imagine that the weather of your city, weather of your town is changing every day. It is not someday it is high temperature, sometime it is moist, sometimes it gets rain. So these are the phenomena we can notice. But then there are phenomena which is very difficult to note with the naked eyes. It is possible to monitor them through machine, which takes care of very, very sensitive developments. Okay, now for example, if I tell you that Mount Everest, which we know is 8,848 meter in elevation from the mean sea level, is rising. And it is rising by a factor of 4 millimeter in every 100 years. Now imagine how long will it take for Mount Everest to rise by 1 meter. So trying to say that several of natural processes are very slow. For example, Everest height is one. The second question which we are discussing all along is global warming, melting of ice over poles, and because of that, rising of sea level. So what will happen? Several areas, especially low-lying area, are likely to get submerged. But will we see it in our lifetime? There is a question mark. Some of us will see, some of us may not see. I think all of us may remember that there was the southernmost point of India called Indira Gandhi Point, south of Andaman, which got submerged when we saw the last tsunami. So there are cases where one could see, but then there are several cases which we may not see. Now here, this particular picture, please see it once again. And there is a question on the bottom. Can you fit it? Now that is the main focus of our today's talk, that if they were one. Now coming from here, you can see that there are few continents, and the blue area is sea. But blue area is not absolutely blue. There are certain long white lines, and you can see why they are here, because even surface of the sea is not even. Somewhere it has got height, and we will discuss it little later. What are those heights? But idea is they are not same. And what we are saying is that continents are probably floating. That was the first feeling which got, that if continents are floating. Subsequently, we worked out that there are several kind of plates. Now I'll discuss little later, but plate you can imagine is a kind of part of Earth crust. It may be on the top, below the continent, or it may be below the ocean. So each one of them is connected. And this shows that there are three kind of plate boundaries or tectonic plate boundaries, which is kind of extension, pulling apart, compression, pulling towards each other, or transform, moving side by side. So anything is possible in this thing. So tectonics, when we are talking, is about the formation of various structures like mountain or ocean. Plate tectonics, we are talking about movement of these plates for development of these structural features. And then this is a theory in geology that explains this thing. Now, what happens when plate moves? You get several signatures. And these signatures are primarily in the form of release of energy. And when energy gets released, it can cause certain damage. So we have taken here some picture of Bhuj, and this shows that how even the road can get, there could be a divide in the road, building could crumple, may fall down, structures may just go bad, and it is just to readjust itself to the released energy. And this is quite momentary. You get normally an earthquake for few seconds, but its intensity could be quite different. And if it comes in an area full of population, even low intensity earthquake would cause more damage. Because what happened when the density of buildings or artificial structure, let us say, man-made structures is very high, and there is a natural adjustment, then those man-made structures may got collapse. They may be houses, they may be bridges, they may be dams or whatever. So we have to take, when we are making the next thing, such heavy investment structures, nowadays we are taking care of how to make buildings which could absorb earthquake. So this is a phenomena, new phenomena civil engineers are learning, and we have learned it from Japan. Now most of the new buildings that are coming in our area are earthquake resistant. But remember, there is a belt where earthquakes are more prone, and those people have to be ready when the next earthquake would be. What are the other signatures? Other signature is when earthquake comes in the sea, then it causes water to move very speedily, and huge or very large waves are formed which can reach the coastal. Japan gets most of its tsunami. In fact, tsunami is a Japanese word, and it is very frequent over there that following earthquake in the sea, they get tsunami and large state of devastation. So this shows how dynamic our earth is. The second kind of dynamism could be through release of energy through volcano. Now, there are several places in India where in world where volcanic activity keeps on taking place. We have got some live volcano. So this particular volcano at Barren Island in Andaman and Nicobar is active volcano. And what happens that not only it provides us a window to the mantle because it brings in material from there, and that material is thrown into atmosphere. When this material is thrown into atmosphere, there are several things taking place. Number one, the atmosphere get dusty or lot of pollutants will come. Secondly, whatever dust that has been emitted out of volcano will settle down through natural process of condensation. So it will slowly settle down. And while it is settling down, it will orient itself into certain directions. For example, if there are some minerals which are magnetic, they will orient themselves as per the geomagnetic conditions, as per the magnetic north. So when they are settling down, they will settle. Similarly, size also play a very important role. So coarser material or bigger material will settle down first. Finer particle of the dust would settle down later. Then let us just see that what are the connections between earthquake and volcano. Now, we have got some area which are highly prone to earthquake, and this area has been demarcated. Now, you will see that these areas are roughly the same where most volcanic activities also take place, which means primarily these are the area which are a kind of weak zones where Earth find it very easy to release its energy. Now, when we are talking about this, see, you can see that there are some parts which are earthquake prone, but not having volcano. For example, our Himalayan region, you will find that volcanic activity is not so intense as it is in other part, but still it is called earthquake prone. If you see this map, earthquakes are more common over here. Now, this is where our today's talk is, that why Himalaya are so prone to earthquake. And another field, another property of the earth, as I mentioned a little ago, that whenever there is a volcanic emission, minerals settle down themselves, keeping in mind the magnetic north pole. Now, I hope each one of you is aware that there is a difference between geographic North Pole and magnetic North Pole. Now, for this, we need to understand why we have got magnetism. If you see Earth interior, in fact, the place where we are sitting, Earth is up to nearly 3,000 kilometers down when we have the core. So that is our interior. Now, last 1,000 kilometers, Earth has got nickel and iron. And this has given Earth property of magnetism. Now, because this iron is in liquid form, so it keeps on flowing and it keeps on adjusting. So what happened that while geographical North Pole is constant, so we know that this is the geographic North Pole. The magnetic North Pole keeps on adjusting itself up to a degree of 11.5 as given in this picture, that it may keep adjusting. So remember, when all natural processes of mineralization are taking place, minerals adjust themselves to the magnetic north. Now, of course, we have got other uses of magnetism. For example, in good old days, when we did not have compass, all the ships were moving, keeping in mind the situation which they could see in the sky, especially night sky, because in night sky they could see several stars and they could identify the directions. But on days when it was not cool, there were some disturbances. It was difficult to see what is there in the sky, or it could be simply cloudy. Then how do you know the direction? So later, when this property was discovered, now we are using compass which works on the principle of magnetism to navigate. So not only our ships or boats are using it, but also we are using it in the aeroplanes or even in our own personal cars. These days, we are using what we call Google Maps or some other reader which help us in taking us to our destination using these principles. Now, plate tectonics is one theory, but before plate tectonics came into being, there was some other terms like dystrophism. So dystrophism used to define any kind of movement in the earth crust, and it was placed into thought that we have got formation of mountain and ocean because of movement of the crust. Okay, and there was one more theory, and this theory was that earth is continuously contracting or shrinking. This concept was primarily because when we got formed from a supernebula, and earth has gone constantly in the process of cooling. And when we were cooling, we kept on shrinking, and this shrinking has caused certain deformation in the surface of the earth. But there was a problem. Problem was that if we are continuously shrinking, then our diameter should get reduced. But Earth diameter remains the same, which means that we are not shrinking. Something else is happening, which is causing several structures like folding or buckling or creation of river basin or ocean basin. So there is something which is happening, and what it could be. So there was a scientist in 16th century who compared it that we are like apple, and if you keep apple in open air for 4 days, 5 days, it start drying up. And it is primarily when Kelvin came, it says that we are contracting because Earth is cooling down. And problem was that nobody was able to further tell us why it is happening. On the other hand, one, we saw that our circumferences, the diameter of the Earth was not changing. Also, there were fossils which are preserved in the rock surfaces. They remain like that. There was no impact of the proposed cooling. So they remained in the conditions they were. So it means that the high temperature which was required for contraction is too unrealistic or too realistic. So other people suggested that there could be something like a tube of toothpaste. You press it, and then the lava will come out. And but then the amount of extrusive rocks which are on the crust, that will be not enough, and we need to see how we could justify that. So there were a lot of debates in that period, and then in 1920 there was a suggestion that it is because that some of the elements within Earth are decaying, and they are getting escape route through atmosphere, and because of this we are getting shrinking, and then there are some other group of elements which are forming denser elements. But of course these all were initial understanding, initial talks, most of it in last century. So contracting Earth theory was widely accepted, but it did not have a scientific thing. So then the next theory came, which saw the jigsaw fit puzzle. So that is the first evidence. We saw how margins of different continents could be joined. And in 1620, there was a scientist called Francis Bacon who studied very closely two continents, South America and Africa. And he said that it is possible to connect them and they get absolutely fit into each other. So most likely they have been separated from each other. And then a lot of scientists in that period started experimenting if geometrically it is possible to fit these continents in one way or the other. There are some areas of overlap and gaps also, but then broadly they could be formed into one. And then there was another scientist called Francis Plesset who suggested that continents were actually fixed, and the name they have used is Pangaea. Pangaea was consolidated piece of land on the Earth's surface. Today we have got, of course, several continents, but Pangaea was the first supercontinent, and it was surrounded by a sea called Tethys. So now today we are saying that this Tethys Sea got flooded and it broke apart the Pangaea into two parts, the northern continent and southern continent. Northern continents were called as Laurasia and southern continents were called Gondwana land. And there are beliefs that there used to be a flood which made this thing happen. And then came Alfred Wegener in 1910, who gave this theory of continental drift. He was born in 1880, and the theory of continental drift came into being in 1915. And he wrote a book in 1915, Origin of Continents and this thing. And what was he basically looking at? So it was not only geographical fit or geometrical fit of the margins of the continent, he also saw that there were certain fossils which were found in South America and Africa. And so he made several fossil connections. Even today, for example, we know that elephant is one of the living animal which is found in India, some part of Asia and Africa. And it is an animal of the size of elephant cannot walk through a sea. So there must be some land connections between Africa and Asia. And that is why it is possible that such a movement could have taken place. There were other evidence. Other evidence is paleoclimate. Now we know, I hope you are knowing the term paleoclimate. Paleoclimate is the two words, paleo and climate. Climate, I hope everyone understands. The weather phenomena over a period of time is called climate. So you know that climate of West Bengal is this, climate of Kerala is this, climate of Himachal is this. When we are talking about paleoclimate, we are talking about past, ancient past. So when we are talking about paleoclimatic evidence, what we do is we study the location of different continents and then see what are the mineral deposits, what are the fossil deposits in the rock surface, and whether they could be off at the same place or they might have moved. So we have identified today that we have got equator, which is supposed to be highly hot and humid. And then we have got regions which are between Tropic of Cancer and Tropic of Capricorn, which are relatively less hotter, less warmer, and also get less rainfall. And then we have got regions which are close to the polar region, where we expect temperature would be extremely low and it would be ice. So if we get ice deposit in a continent, then we believe that that continent must be at some time in the geological past be at the poles. Otherwise, how you will find such deposits in areas which are now close to equator? So if we see this band of Latin America, where we are finding sea-based or polar-based, ice-based deposits, it means this area was sometime in ice. Similarly, reef deposits are supposed to be on the equator, but if you find them somewhere else, then it's a cause of concern. So we have tried to work it out how desert deposit, reef deposit over several hundred millions of years have been found. And that shows that position of equator today or the position of continent of equator today is not the same as it was in the past. So poles and equators are fixed, but then continents must have moved. So there are several glacier deposits which we find in several regions which today are not that cold. So that shows that there are regions where there have been moving across the geological past. Then there is another parameter, and that parameter is of craton. Now, cratons are very, very stable landmass. For example, in India, we say South India craton, because that area is not supposed to witness, is rather flat. It doesn't have very high topography. It doesn't have very huge depressions. And this area is not having any volcanic or tectonic activity in last several millions of years. So if we connect craton also, then we can see that which are the area which are stable and which are the area which have been recently formed. Now, of course, in geology, when we are talking recent, it doesn't mean just now. It means few hundred millions years. Remember, Earth is nearly 5 billion year old. And we know mostly information about last 450 million years. Before that, the period before that, we do not know much, but we are trying to learn more and more about that. Only thing is life was not there, and the formations of those time are rather stable, so they could be cratons. And today, or in last 450 million years, whatever formations are being formed are called younger belts. Now, another thing we have to see, I showed you a map earlier of the seismically active area or earthquake prone area and volcanic area. Now, if you see the map, this map, here we have shown you areas of high mountain, and you will see that high mountains have got some way, a linear profile. It is here, it is here, and it is here. Now, of course, if you see that this portion is quite dense as compared to other parts of the world. So we have got flatland, which is shown as green, and then we have got this red color, which shows the kind of height. So the denser the color, more the height. So what we are saying is that they are not randomly distributed. They also have a connect. Now, if you see our own country, we are continuously moving. And what we are doing is that we are colliding with the Eurasia plate. And because of this collision, we are getting this kind of tectonic activity which has formed Himalaya. Himalaya are called fold mountains. Why they are called fold mountains? It is like if two plates are colliding, you might have seen on the road or at least on the movie, if there is an accident and two cars or two bus collides head on, what happens? They will raise themselves. So Himalaya are raised because Indian plate is colliding with the Eurasian plate. And this is a process going on even today. That is why earlier I told you that Mount Everest is also rising its height. But this process is so slow that we would hardly monitor, or it hardly affects our life. So, but India is continuously moving, and we were at a time nearly 5 million years ago, 45 million years ago, 10 degrees south. Today, entire India is north of equator. How does these continents or these plates moves? So there are basically three models. So one is pulling it apart. One is when they get collided, and third when they move side by side. Now we will discuss each one of them, but let us understand why it is happening. So the process why it is happening is that Earth is still cooling. That is one phenomena, and lot of heat is generated by the radioactivity, and then heat is transferred via convection. Now let us see one home example. Home example, you can take a beaker or any transparent vessel and you boil the water. When you will boil the water, you will see that if you are putting it on the burner or the heat source, then water molecules will keep moving. So first of all, the lower surface will get the temperature rise, and once it gets warmed up, it will move up. And once it moves up, it will displace water molecules on the top layer because that is relatively cooler. So the cooler part will come out and it will get exposed to the heat, and then it will again warm up. So this process keeps on moving. Same process is happening in the nature, that there is a constant heating up, and this is heat source. We are using it volcanoes on the volcanic activities, and because of this there are continuous movements of plates. Now this is in the example I have shown only one kind of a movement, but we will discuss other movements. So just to keep you on some factual information, that Antarctica was once had the warm climate and it was near equator. So it has moved from equator to the polar region. Similarly, Indian subcontinent has also moved. We were part of the southern hemisphere and we have moved to the now northern. And other continents are also constantly changing position. Now this is a geological time scale, and this shows Earth from its formation, and we could say that there have been periods. Now each period is marked by change in some basic parameters: lifestyle, temperature, pressure, cooling effects, rock formations, and like that. And there have been some records, but the period we know more is something what we are calling is post-Precambrian. And here we know that there have been several times when the Earth's atmosphere has changed. We have been into ice age, we have been into a warmer planet, and there have been several animals which have come on this planet and have got extinct now, and we know very little about them. But one of the most famous animal which have lived and ruled this earth is dinosaur, which was first seen 248 million years and vanished 65 million years ago. So nearly for 180 million years, those animals ruled. But remember, the land says, the nature says, nothing is here forever. And each one of us have to keep changing. So earth processes are regularly happening. Earth is very dynamic. Now, when we did not find an answer, when Wagner could not find an answer why this earth, why this plate tectonics is happening, so people started seeing it in the sea. And in sea, you could find several structures. Sea is simply not water enough, but there are a lot of other things. So the floor where we stand up is called continental shelf. This is primarily the land. And then there is the area of depression, which is called continental slope. And then we have got several canyons, which keeps flowing into the sea. And then there are area where this, because of this, there is some forces which puts continents to rise. And then there are deep plains here, quite away from the sea, and they are very, very deep. So here, the depth of the sea is rather shallow, but here they are quite deep. And what is happening, if you see deep ocean, it's not a flat surface. You will see several undulations in the sea. And these are something what we are calling as sea mounts. And remember, if we have to talk about elevation, then the highest mountain is not Everest. There are, highest mountain as far as height is concerned is not Everest. Because when we are taking height of Everest, we are taking it from mean sea level. But if you see that there are mounts in the sea also, they have got more than 8,848 meters height. And I would leave it to you to find out what is the name of such mountains which are higher than height of Everest. Okay, so these mountains explain the phenomena, what we say is spreading of sea floor. So this is something, a picture of mid-Atlantic ridge. We have also got it in the Indian Ocean. So virtually all the oceans have got such ridges, which are pretty long and are forming. And now how sea floor expands. There are three phenomena. So as we discussed earlier, so what happens whenever there is an activity from the surface inside the earth, then this activity or the heat release will cause several disturbance. And these disturbance would also ask plate to move. And plate could move either from away from each other. That is one kind of movement. Second movement is when plate, one of the plate will go down and get submerged into another plate. So when this activity is taking place, then the land surfaces or the continent or sea will move away from each other. But when such a subduction is taking place, obviously one of the plate will get risen up, and this will cause some trenches, some hills to be formed. And there is a possibility that they just move from by side. So when they are moving by side, they will cause least disturbance. Now let us just understand one of them. So what is happening, that volcanic activity is taking place, and one of them is a softer plate. Okay, one of them is relatively harder. So what happens that when softer plate comes and collides with a harder plate, softer plate will get submerged. They will form trenches. Okay, I have given example of Tonga Trench, but they will get trenches. Have you ever seen a real accident of train with a bus or a car? What goes up, which is light. Here, what is happening because of the volume? Size is too big, so they can't fly it up. So it gets submerged. The other example is like mid-oceanic ridges. So there is volcanic activity which is causing this plate, and then they are moving apart from each other. When they're moving apart, what is happening? So it is a kind of depression they are causing, but at the same time, because volume has to be same, so this area get folded up or raised up. So we have formation of mid-oceanic ridges. And then the third one is strike slip or movement by side, which causes least damage. But since these are some of the activity, you will find that, for example, this chain of mountain gets dismounted. And you can see on this plate here, but at a distance on the other plate. So when we are talking about these things, remember it is something like that lithosphere is our earth crust and asthenosphere is a kind of top layer on the lithosphere. So the asthenosphere moves as if we are moving our things on the conveyor belt of airport. So it carries our things from here to there. And there is also something like we are calling munch and crunch, that subduction of oceanic plates or undercontinents. So one plate will get submerged, so it is munching, and then it is colliding. So like India is colliding with Tibet and China. So constantly moving. And these kind of activity will cause earthquakes. So when they are colliding, when they are moving away, Earth will get some adjustment resulting into earthquakes. And when they are sliding by side, even then there could be some activity, but mostly inactive. If we see the map of ocean floor, you will see that there are areas marked in red which are of low depth. Okay, and then areas which are marked like this have got more elevations. So when we are talking about oldest sea floor, that is only 200 million years old. But when we are talking about land, land is 5 billion years old. So we know there is a constant activity which is happening on the sea floor. And sea floor is constantly getting reformed. It is causing continents to move. It is causing plate to move. It is causing continent to move. And this is how we are going. But question remains, our diameter is same. So whatever is happening within a given diameter. So when sea floor is spreading, there would be some other activity causing earthquake, creating some more mountain, because the portion which have been struck, they would like to get denser in volume. And sea floor is so young as compared to continent, as I said a little ago, it is constantly getting reformed. We are having subductions, law of conservation of the ocean floor is there. And then once again, we have to see plate boundaries. How do we know about these boundaries? There is a study, what we say called bathymetry. This helps us in identification of margins of the plate and how we study orientation of several parameters over there. Occurrence of earthquake also help us in knowing what are the area which are active or weak zones and where there could be some movements. Then we are looking at deepest earthquake and the convergent boundaries which can cause subduction zones or trenches. We are looking at downgoing plate breakages because of earthquakes, and it is something like potato chips breaking of the bean dip. So these are the studies that help us in understanding plate movements. And these are some more, if I could say, more clear for you, the way plates are there and what kind of stress is there, what kind of movement is taking place. And this is putting you more closely, more neatly that there are different plates and you will find that within a plate there are several microplates. So what is the proof that seafloor is spreading? Wagner couldn't answer because that time the studies of geomagnetism was not that clear. So nobody knew if it has got anything to do with geomagnetism, and they were using liquids, but then how it is happening. So as we know that magnetic has a property where we could identify north and south, and anything that has got magnetic property will settle down in the orientation of magnetic north and magnetic south. So when we see the rock surfaces, we will find that on a given continent, the signature of magnetic orientation of minerals in the rock surface is not the same. And in some continents, you will find it in one direction. In some continent, some other continent, it would be in different formation. And we fully realize that when there is a consolidation or freezing of minerals, they will orient themselves as per the magnetic field. So anomaly, what we are recording in the field is whether they are magnetic normal or magnetic reverse. So there are studies by Wine and Matthews who noted that magnetism could explain seafloor spreading. So again, taking the same three examples, they have suggested that this is the normal magnetism which is happening, and what could be the places where it would be normally in this area, there would be normal orientation of minerals as normal orientation means normally in direction of magnetic north and south. But here in this area, this band, which is not affected by magma, there would be rivers, and then there would be dikes, which are normal. So they have tried to explain that how this orientation of magnetic polarity, normal and reverse, could help us in understanding the spread of seafloor. So there are, we can say that there are three kind of forces which is happening: slab pull, ridge push, and transformation. And what Wagner concluded that the mountains were once, continents were once joined, and they must have moved apart over a period of time. Contracting earth theory is not consistent, and Wagner proposed a mechanism of continental drift, pushing of continental by gravitation. But of course, we know that it is not true. So the large supercontinent was called Pangea, and we have got splitted it. Then we studied fossils and glacial deposits. Wagner could not find the answer why it is happening, but then other scientists mainly Henry Hess, he came up with this theory of plate tectonics, which was primarily caused by the volcanism on the ocean basin and resulting into breaking of plates, continents, resulting into spreading. So with this, I would like to conclude, and I am just trying to show you how we have been moving in the geological past. Thank you very much.
Hello.
Yeah.
Thank you, sir, for your enlightening lecture. We came to know so many things which was almost unknown to us. Sir, actually, this session is now open for question and answer. All the students who are attending, they can just put up their questions in the chat box, as well as they can ask. And before all these things, sir, actually, I'll request all the attendees to make their video on so that we can have a group snap for this program. Hello? I request all the attendees to make their videos on. I'm not able to see any student. Please make your videos on. All the research students of CGCRI, as well as school students who are joining this, who have joined this program, please make your video on. Okay. So students who have a question, please you may ask Vaishnav sir. Hello?
There is a Smith Mitra. He is talking.
Yes, you may ask Vaishnav.
No, ma'am, I have no question.
Okay. Anybody else who has a question?
No, ma'am.
No, ma'am.
Student attendees, research scholars?
No, ma'am. No, ma'am.
I think we have a question in the chat box from Ognivo Sashmal. Sir, here is a question. How did the continents drifted away from each other?
No,
So,
as we discussed in the later part of the lecture, that these continents got drifted because of the activities taking place on the sea floor. And volcanic activity is providing them energy, and following that, what is happening, that lot of energy is released and three kind of movement is possible. So one, where continents move away from each other, causing a depression. Two, when they come and collide with each other and get raised up. And three, when they are moving side by side. So it's a constant activity that has been going up, and this has caused continents to move away from each other.
Ivo, did you understand? Do you have any more question? Hello?
No, ma'am. No, ma'am, I have understood it.
Okay. So the next question is from Diptodip Paira, and yeah, it is the same question. What I can see, how did the continents drifted away from each other? So okay, sir has already replied. I think Diptodip, you understood it. Hello. Not audible. Anybody else has a question, and from CGCRI as well, research scholars who are attending this program?
Ma'am, I have a question, one more question.
Okay, you can please ask.
Sir, why did the region in the Himalayan areas is earthquake prone and not the volcanic prone region?
Okay, you know, here in the Himalaya region, the tectonic activity or the earthquake activity is taking place because of collision. And it is not the naturally occurring weak zone of the earth. So in other earth areas which are weak zone, they get both earthquake and volcano. But Himalaya is not a weak zone. Himalaya only activity we are having is continuous movement, continuous northward movement of the Indian plate and southward movement of Eurasian plate. So that is what it is happening. And we are not having volcanic activity in Himalaya.
Is this clear?
Yes, ma'am.
Sir, we have one more question actually. Shamya Das, he is asking, can tectonic plates break while they collide?
Oh yes, as I showed you in one of the maps, that there have been areas which we are calling as gaps, and somewhere there are areas which have overlapped. So both kind of possibilities are there.
Okay, so Samya, you got your answer. And sir, one more question from Prantik Mishra. He is asking, what is abyssal plain?
Oh, abyssal plain are the deep sea, the surface of the sea, which is away from the continent, and it is quite deep. Whenever we are using the word abyssal, it means quite deep. So abyssal, they could be plain, they could be hillocks, but when we are talking about abyssal plain, it is long surface which is plain in character, and basically on ocean floor, quite deep.
And Preeti, one student, she has written that I think it is not Mauna Kea but Mauna Kea volcano on Hawaii is the highest mountain on the earth, and it is higher than Mount Everest. Actually, sir, also I have checked, it is nearly 33,500 feet. And she is asking that, is this correct for the question asked by sir during presentation?
No, it is not the answer of my question. In fact, there are ridges in the ocean which has got more height. So be very careful whenever we are talking about elevation, it is Everest. Because elevation we are taking only from the mean sea level. Okay. But when we are talking about height, for example, what is your height? So you will say 5 feet some inches because you are always measuring it from the surface where you are standing. Okay. But so if we are talking about height, so there are mid-oceanic ridges which are more higher than Everest. But because Everest is sitting above sea level, there it has got higher sea level. So Mauna Kea is not the highest. There are deep inside sea, more higher elevation.
Yes, thank you.
Okay, sir. So if there are no more questions, sir, I have a small question as well.
Please.
Sir, actually, what we heard is this Gangetic plain, because Kolkata is in the Gangetic plain, is very much earthquake prone. Earthquake prone. So, is it true? And how do you decide about this mechanism actually?
So if we see the entire map of India, so we have divided into seismic zonation. So the range which is currently Himalaya is very high, and it has got the rating of 4 to 5 depending upon the location. But then Indo-Gangetic plain are the next weak zone. There is a strong belief that maybe after millions of years, these are also converted into mountain, because Indian plate is constantly moving north, and Indo-Gangetic plain may form a mountain, something like Shivalik. Okay, so Shivalik was a river, but it got buckled up and formed into a mountain just outside Himalaya. So Ganga could be another river that may get buckled up because of the constant pressure that is coming because of Indian plate and may form a mountain. But that process may take millions of years.
So still there is time, sir. I mean,
yeah. But in between, we'll get exposure to seismic activity because this remains a weak zone.
Okay, sir. Thank you. So now I will request Dr. Anirban Dhar, Senior Scientist FOPD, to deliver a vote of thanks. Thank you. Thank you very much, sir.
Welcome.
Thank you, Dr. Chakraborty. Good afternoon, everybody. So finally, we have come to an end of today's 4th virtual lecture series of CSIR Jigyasa Student Scientist Connect program. So though we have planned this should be an open to all program, but due to this pandemic situation, we are not able to do so. Anyway, but still we are happy that we could successfully organize today's program, and it has been only possible due to sincere support from everybody associated with this event. Hence, it is my great pleasure to propose a vote of thanks. First of all, we are thankful to CSIR for giving us this great opportunity to host today's event. I convey my sincere thanks to Dr. Suman Kumari Mishra, Director CGCRI, for her kind support to organize this program and opening remarks and render continuous support and advice towards organizing today's event. I must mention our deep sense of appreciation for Sri Shitendu Mondol, Chief Scientist and Head of Specialty Glass Division, and Jigyasa Nodal for his constant effort to make this program flawless. He motivated the whole team with his guidance and encouragement in the organization of this great event. I sincerely thank our Chief Guest, Dr. Bharshanai Sir, for kindly accepting our invitation in spite of his busy schedule and delivering a very insightful lecture in today's virtual lecture series. Thank you, sir, for your kind acceptance. I also express our gratitude to all the participants, including respected teachers from different schools across our state, and most importantly, the students who have been the motivation of this particular event. As a token of appreciation, I should say that the students are the main part of this program, so all the students should participate in the same way in the future as well. Last but not the least, I also wish to sincerely thank all the core members of the Jigyasa program, Dr. Prashanta Kumar Sinha, Dr. Kaushik Bishwas, Dr. Shubhadeep Bodhok, Dr. Devdulal Shaha, Dr. Shaurabh Nag, Dr. Atiyar Rahman Mulla, Dr. Milan Kanti Noskar, Dr. Ganesh Shahu, Mr. Shantanu Sen, Mr. Somjyoti Bosak, and our colleagues from IT division, especially Mr. Ognibe Odhikari, and everybody who has been associated directly or indirectly with this special event. So with this again, I would like to thank all of you on behalf of the organizing committee. Stay safe, healthy, and wish you all advance happy puja. Thank you all.
Namaskar.
Thank you, Vasni. धन्यवाद.
My pleasure.
Thank you, sir. Thank you so much for your kind help and kind support.
Yeah, my
We are
pleasure.
really very grateful, and definitely your deliberations and lecture has been enriching with the knowledge base generated in the young minds, particularly the school children. I request all the school children, please, because we are organizing on every month. So the next webinar may be the first week of November. Soon you will be keeping informed, and please listen to that and come out as a scientist of Indian origin, pertaining to the Indian science and technology. This is my earnest request to the young minds. Thank you so much for your all patience. Okay, Dr. Jui, please.
Yes, sir. Varshana, sir, we have a couple of more questions. Do you
Oh,
have
yes.
some?
Yeah.
Yes, sir. So there is question from Sampad, who is asking that, sir, will all the continents stay above the sea after 500 years?
No, 500 is a too little period. You know, because we are talking about journey of the Earth for nearly 5 billion years. And what I told that we know mostly about last only 545 million years. So 500 years is a pretty small period, and Earth would be virtually the same as it looks today.
Okay. So Shampad, you have got your answer. And sir, there is one more question, and it has been asked by two students, a similar question. Aniket Patra, he is asking, sir, can the Earth be destroyed because of the tectonic plates movement? And the same question has been asked by Supratit Datta as well.
Well, it's a hypothetical question. One thing I can tell you that Earth is a very, very dynamic planet. Nature has gifted us with so many virtues which other planets do not have. So, like air, water, life, these are not on the other planets. And in our own wisdom, we have been trying to do away with some of the activities, natural activities, which we could, which is going against the law of nature. Actually, you may say. For example, we know that several celestial bodies may collide with the Earth, and we are trying to break it before they collide with the Earth. Okay, so that is a human effort, but it's too small. Okay. Through its internal processes, Earth will continue to be the way it is. There would be some reorientation of the land masses and water bodies, but Earth would remain. It is such a strong system.
Okay, so students, you have got your answer. And with this, we now come to the end of the session. I would like to thank our director, Madam Shitendra Mandal sir, Dr. Sinha, to give me this opportunity to moderate this program and come to know about Dr. Varshana's talk. So much enriching and so much enlightening about this new subject. So many things, so many new things about this subject, and for making this important event successful. And we look forward for the next Jigyasa webinar in the upcoming days. Thank you all.
Dr. Varsini, I'll be in touch with you very shortly. I am sending an email to you. Please respond to that.
Sure. Thank you.
Okay. Okay, sir. Namaskar. Namaskar.
Yeah.
Thank you, Basu. I am leaving.
We have, ma'am, we have one more question at the last moment. I think Dr. Varshana has left.
Yeah.
He has left. Okay.
Yeah, we should close it. We should close.
Okay,
Yeah.
okay, sir. Okay, sir. Okay.